Welcome to video 2, and you're going to have to take some notes on real numbers now. For me, you're not getting these from the book, so you're getting these from me. So the first thing I want you to do in that space right there, right underneath example 5 where it says notes on real numbers, I want you to draw a number line. Oops, I got to get myself a pen. I want you to draw yourself a number line pretty much all the way across. I'm going to have 3 marks for 3 main numbers, and those numbers are going to be 5, 6, and 7. And then between 5 and 6, we're going to put every decimal tenth. So 5.1, 2, 3, 4. Here's 5.5. I'm going to make it a little bit bigger. And then 6, 7, 8, 9 going to 6. So this would be 5.1, 5.2, 5.3, etc. 5.6, 5.7, etc. Between 6 and 7, we're just going to go right here at 0.5, kind of in the middle. Now, these real numbers, we're talking about approximating square roots in this video. So I know that the square root of 25 is 5. I know the square root of 36 is 6. And I know the square root of 49 is 7. So now, when we're approximating square roots, it's because we don't have perfect squares. So that means somewhere between 5 and 6 falls the square root of numbers between 25 and 36. So let's take, for example, the square root of 28. So somewhere in here, the square root of 28, that's going to be pretty close. That's going to be pretty close to the square root of 25. And if you use your calculator, you find that the square root of 28 is 5.29. So that means it's going to fall right about in here somewhere, 5.29. Of course, it repeats and it goes on and on and on. But the square root of 28 falls right there on our number line because it's right here, 5.29. And the square root, let's go with the square root of 34. The square root of 34 happens to be 5.83, and it goes on and on forever because it is an irrational number. So that means 0.83, it's going to be in here somewhere. So the square root of 34 is 5.83 something. So that's where it falls on the number line. So when we're approximating square roots, we're going to approximate these decimals that exist with these non-perfect square numbers. And so, real quickly, where do you think would fit the square root of 39? Just off the top of your head, you think the square root of 39 is more or less than halfway between 36 and 49. So if I have these two numbers, is 39, the square root of 39, more or less than halfway? Well, yeah, off the top of your head, logically, it's less than halfway. Notice the distance between any two perfect squares is always an odd number. So the square root of 25 to the square root of 36, that's 11. The square root of 36 to the square root of 49, that's 13. And guess what? 49 to 64, that's 15. Yeah, it keeps increasing by 2, and it's an odd number. So you can kind of look at a number and have a rough estimate just in your head on whether that decimal for a non-perfect square is more or less than 0.5 between perfect squares. So let's talk about how to do this. We're going to do a couple examples. Stick with me. We're going to be approximating some square roots. We're going to estimate to the nearest integer a and the nearest tenth b. So here's how you do it. First thing you do is you write your target number. Your target number is the number they're asking, the square root of 14. And then you say to yourself, well, what are the two perfect squares on both sides? The one that comes before, that would be the square root of 9. The square root of 9 is 3. And the one that comes after, the next one, that would be the square root of the square root of 16. That is 4. So the square root of 14 lies somewhere between 3 and 4. Now, which one is it closest to? Because A says the nearest integer. Okay? So, let's see, between 9 and 14 is 5, and between 14 and 16 is 2. So which one is it closest to? That's right, it's closer to 16. So the answer to the nearest, estimating to the nearest integer, would be 4. All right? So let's go to B. B is a little tiny bit more complicated, but not much. So let's take a look. Here's how it's done. First of all, I know that the square root of 14 falls between 3 and 4. So my answer has to be 3 point something. It has to be 3 point something. And to find that decimal very quickly, I take the distance between the target number and the one before. So between the square root of 9 and the square root of 14, that's 5. And I divide that by the distance between the two perfect squares. So between 9 and 16, that's 7. So now I have this fraction, 5 over 7. And the way to do this real quickly without a calculator is just put a decimal 0. How many times does 7 go into 50? That's right, it goes 7. So my answer is 3.7. That's my approximation. If you use a calculator, you would find that the actual square root of 14 is 3.74, ... It goes on and on forever. Let's do another one. Okay? Let's do the square root of 52. So we're going to write down our target number, the square root of 52. And then what are the perfect squares that come before and the perfect square that comes after? So the one that comes before is 49. The one that comes after is 64. The square root of 49 is 7. The square root of 64 is 8. And 52 is what? Closer to 49 or 64? That's right, it's closer to 49. So our answer to A is going to be 7 as an approximation to the nearest integer. For B, we recognize that the square root of 52 has to be between 7 and 8, so the answer has to be 7 point something. So 7 point something, 7 with a decimal. And just by looking at it, it's closer to 49, and it's pretty dang darn close to 49. It's less than halfway. It's only 3 different. So we know it's between the whole thing right here, 49 to 54 is what? That's right, it's 15. So it's only 3 away. It's going to be less than 7.5. So right there, we just found the two numbers that we need to divide. We take the distance between the target square and the square that comes before. That's the square root of 49, and that's 3. Dividing it by the complete distance between the two perfect squares, 15. Add that decimal. 15 goes into 30 2 times. My decimal, 7.2, is my approximation. Moving right along, our next one is the negative square root of 91. I'm using different colors this time. The perfect square that comes before, remember we're on the negative direction, so before is going to be over here, and that's going to be 81. The negative square root of 81 is negative 9. The one that comes after on our number line that goes this way in the negative direction is the negative square root of 100, and that's negative 10. Right? Outstanding. So, knowing that, we have to say, well, to the nearest whole number, A, which one is it closer to? The negative square root of 81 or the square root of negative 100? Well, it's 10 away from 81, it's 9 away from 100, so it's slightly closer to negative 10. Slightly closer. And now, we notice we got to get we have to do B to the nearest decimal, the nearest tenth, and so we take our distance between negative square root of 81 and negative square root of 91, and that's 10. And the distance between 81 and 100, that's 19. And we put a decimal, and we put our 0. 19 goes into 100. Well, 20 goes into 100 5 times, so it's approximately, negative 9.5. Okay, so negative 9 going in this direction, and then it's got to be 9 point something. I didn't write that down, but I should have. Negative 9.5. It's slightly more. It's going to be negative 0.9 something something. It's slightly more than 9.5, but again, we're approximating to the nearest 10. Let's do one more. The negative square root of 72. So here we again have a negative number, and that's going to be the negative square root of 72. The one that comes before is the negative square root of 64, and that would be negative 8. The one that comes after is the negative square root of 81, and that is negative 9. So then we decide which one are we closer to? Which one are we closer to? Are we closer to 64? That's 8. And 72 to 81, that's 9. So we're closer to the negative square root of 8. So A is negative 8 to the nearest integer. Now the nearest decimal, B. Here's where I'm going to get you again. It's closer, or it has to be between negative 8 and negative 9. It has to be negative 8 point something. It can't be -9. That'd be too much. All right. So we know that the distance between 64 and 72 is 8. We know that the distance between 64 and 81 is 17. Put our decimal in there, and that goes approximately 4 times. I know that 20 goes into 84 times. 17 is not going to go 5 times, so we're going to go 4. So -8.4. And that's how it's done, people. It's pretty straightforward. We got to practice it a couple times. So let's go to our quick write, which says you're going to do these two, the square root of 41 and then the square root of 118. I'll do a -1 in class, but I want you to practice on these two. Very important. So the square root of 41, the square root of 118. Remember, target number. Get the one that comes before, get the one perfect square that comes before, the perfect square that comes after, and practice those things that I just showed you. All right, get a quick break after you're done with those two, and then come back for our last video tonight.